All right, guys, welcome to another episode of Cuda Education. This is the pipelines.cpp algorithm. I'm just finishing up the very last piece that I promised I would finish up in the last video. Shout out to the author of this algorithm, as you can see here. And if you want to join in on the fun, install Vulkan on your Windows-based machine with a Vulkan-capable GPU, and also install these examples. Tutorial number 1 and tutorial number 13 are down below in the description. Let's get to it. So this was the last piece, uniform.descriptor, and then the VK update descriptor sets, right? So this uniform.descriptor, what it's basically doing, it's associating the descriptor set with the actual memory that we're dealing with. So if we go to we could go to lookup, go to definition. So we look up uniform buffer, right? It's just a buffer. But then if we look at what this variable is, we could see that it's basically managing the memory, right? It's managing the memory. So in the previous video, I talked about host visible and host coherent, basically saying that, okay, it's memory of type uniform buffer, and then it's the host and the device memory, the GPU memory, all of that stuff. Basically, it's visible to everyone, and it's kind of accessible and shareable with everyone, right? So what it's doing basically is it's associating where is it? Come on. Right, it's associating that memory discussion with the actual descriptor set piece, creation. Because remember, with the descriptor set, we actually had we have a descriptor set layout and a descriptor pool where we're managing, the hardware resources and mapping out, what kind of memory and what can access that piece of memory and stuff, right? So we're associating that descriptor set conversation with the actual memory piece, right? So if you look at the function, right, descriptor set here, you will see that we associate the two, but then we use the handle uniform buffer.descriptor to kind of put the two together. So if we go to right descriptor set, we see you have a set type binding and then descriptor buffer info, right? So that's this piece right here. And then descriptor count of 1, right? So it's basically associating the two. So it's not the uniform buffer variable itself, it's uniform buffer.descriptor, and that's what's going to be the handle for this association here. And that's pretty much it. You could definitely, what I suggest is you go to the spec, look up this term, so you could see exactly what it's referring to, right? So you understand it's, sort of defining the structure and everything. So if you go to the spec, it will give you more information. And then we just basically update the descriptor set. So you could also look up this function on online, and you will basically get information on what all of this is. I mean, I don't think this is going to show us anything. Device, descriptor write count, descriptor writes, copy count, right? And there you have it, guys. So that's this piece. The next set of videos that I'm going to do, I'll give you a little sneak peek. The next set of videos I'm going to do is going to be talking about GLTF. So you know all those are really amazing renders and images and rotating images and you know all the different pictures that we see on our on our uh on our you know on the algorithms, right? The different you know, even the pipelines and everything, all that's it's 3D assets. Okay, so there's a thing called GLTF. It stands for Graphics Library Transmission Format. It is sort of developed by the Kronos group, which are the same people that created the Vulkan API. And basically it's a way of efficiently uh what's the word, efficiently communicating or sharing 3D assets, 3D models, and the like, for people to use in their computer graphics applications in whatever format or form it may be, right? So it's sort of a standardized format. There are like several different formats for 3D assets, but of course things need to be standardized and stuff, and Kronos Group is trying to do it. It generally is considered to be memory efficient, and also you know, have scene information, and you know, not just the object itself or the image itself, but it has scene information, surrounding information, all that stuff. Don't want to get too much into it in this video, but I think for you creatives out there, for you visual artists out there, people that's really into more of the presentation and the pixels on the screen stuff and not necessarily the coding, I think you will enjoy that video. So that's going to be my next series. And then right, so I'll focus a little bit on that. It is important to computer graphics to have assets in your scenes, so and to be able to, you know, you could even buy assets, and you could share assets, and you could sell assets and stuff, right? So it is definitely a lane for people who are in the computer graphics scene. So that'll be my next series. Like and subscribe, share. If you have friends that are interested in computer graphics, why don't you all get together and work through these examples, work through the code, work through the tutorial. Tutorial number 1 and tutorial number 13 will help you to get Vulkan on your Windows-based machine with a Vulkan-capable GPU, and get you down the road of computer graphics. Invest in yourself, believe in yourself, learn something, and that's it. All right, guys, thank you for watching. Have a great day.